Hello, in this video we're going to consider past paper May 2025 Analysis and Approaches high-level course, question number 7. It's paper 1, non-calculator paper, and let's have a look. So it is 5 marks, and definitely it's about the complex number. So we have to consider the complex number z is equal to iota minus 3 in power iota minus 1, and we have to write integer 3 in the form e in power a. Okay, at the first glance probably this question looks a bit confusing, but if we will understand that how to make 3 as a power of e, yeah, this is a question. But if we will look at this case, if we will just switch the sides, left hand side with the right hand side, we will see that it looks like this, yeah, right? So what we can do now, we can make we can remember that the a log b in power in base a is equal to b. This is a basic logarithmic identity. That's how we will get the ln here. So it's actually logarithm 3 in base e, right? So in this case we can say that e in power ln 3. So that 3 is equal to e in power ln 3. That's how you'll get 1 mark. Okay, now let's turn to the part b. So it says, hence giving your answer in the form p cosine ln q, where p and q are rational numbers, find re z, yeah, so real part of z. Okay, now we have real part of z. So now what to do? We can use this 3 here. Okay, 3 here. So we can write, instead of 3 in our given data, we can write that it is e in power ln 3, yeah, and in power iota minus 1. So now we have to deal with this. We have to understand what to do with this. To do the next step, we have to remember that the complex number in Euler's form is equal to z is equal to r e in power theta iota, right? Now what we have from this part, we have iota. We have to have iota here, but we have iota minus 1. So that's why we have to convert somehow iota minus 1 just to iota. Okay, what to do? Let's switch using the property of exponents. We can make this operation. So multiplied by e in power ln 3 in power negative 1, yeah? So this is the first step. Now after that we can make the second step. So we know that this part is 3, yeah? It's just simply 3. So we can write that it is 3 in power minus 1 e ln 3 iota. So I just switched the numbers here, switch the factors, and now the final we will get a z is equal to 1 over 3 iota ln 3, yeah, like this. Okay, now what we can do, that here this one is ratio, this is a ratio, this is a radius, yeah, and this one is theta. So r is equal to 1 over 3 and theta is equal to ln 3, right? So now you see that this form really looks like that. It means that we can state that real part of z, it's actually, if we will use r cis theta, it's equals to r cosine theta. Okay, that's how it works. So now we have to take only the value of radius and the theta. So the real z is equal to radius for our case is 1 over 3, yeah, 1 over 3. This case 1 over 3 we just plug here. So 1 over 3 e cosine theta, cosine ln 3. Yeah, so this writing a bit confusing, but it is correct. This is correct. That's how you'll get 2 marks for the part b1. Now let's turn to the part b2. It says real part of 1 over z. So our complex number is this one, yeah? So let's underline that it is our complex number, and it means that 1 over z will be equal to 1 over 3 e in power ln 3 iota. Okay, and now using the property of exponents, we can say that it is 3 e in power negative ln 3 iota, right? Negative ln 3 iota. That's how you will get another 1 mark. And to finalize the question, we have to just make a short simplification. We can say that it is equal to cosine, yeah, we have to write it in terms of cosine. Now we know that the radius here for this case is 3 and the angle negative ln 3. So that's why real part of 1 over z is r cosine theta. Our r here is 3 and theta is negative ln 3. That's how you'll get another 1 mark, and total it is 5 marks is yours. This is a question about the complex number. I hope this question clear for you, and please write any comments, reaction. I'll be happy to read and answer. See you in the next video. Goodbye.